All right, in this example, I'm going to use the distributive property to eliminate grouping symbols. Then I'm going to solve. So if you notice, I've got the variable a on both sides of the equal sign, but also notice that the a variable is locked inside these grouping symbols or parentheses. I'm going to get them out. I'm going to take I'm going to take the a variable out of the parentheses by using the distributive property. All right, so here I go. Well, I know the distributive property is where I multiply the outside value by the first and second value inside the grouping symbols. I do need to watch my sign. So here I go. I might also need to do it on this side too, by the way. So negative 10 times a and negative 10 times negative 5. Let's do this one step at a time. So 4 times 2a is 8a, and 4 times negative 1 is negative 4. Bring down my equal sign. Negative 10 times a is negative 10a, and negative 10 times negative 5 is a positive 50. Remember, negative times a negative is a positive. All right, now what we're left with is an equation just like we worked in the last example, where I want to bring the a's to one side of the equal sign and some solution or constant value on the other. Remember how I did that? So let me bring the a's to this side. If I've got a negative 10a here, I can eliminate this negative 10 on this side by adding 10 to both sides. So plus 10a plus 10a. All right, let's take care of that. So 8a plus 10a equals 18a minus 4 is equal to, well, this cancels, so I end up with just 50 on this side of my equal sign. Not bad. Now I want to continue. I want to continue moving things. So I've got all my a values, I moved all my a values to this side of the equal sign. I now need to move everything else over to the other side. Okay, so I have a negative 4 over here. I'm going to eliminate that by adding 4 to both sides. Okay, so bring down 18a. That leaves me with 18a. This cancels to 0. 18a equals 54. Can you guess what we're going to do next? Well, we're going to divide both sides by 18. That will isolate or bring a by itself. Okay, well, this cancels to 1, or 1a, and 54 divided by 18 is 3. Now, how can I check that? Well, if I substitute 3 back into my original equation and solve it, I can make sure that both sides of the equal sign are in fact equal. Well, let me go ahead and try that. Okay, I think I can actually, yep, I changed colors this time. All right, so I'm going to rewrite the equation, and anytime I see a, I'm going to plug in 3. So 4 distribute or plug in a of 3 minus 1 is equal to negative 10 times the difference of 3 minus 3, the difference of 3 and 5. Okay, so let's go. I'm going to rewrite this. I'm going to now combine these values. So 2 times 3 I know is 6. I can do that. Remember, I'm taking it one step at a time, being careful with my math. 2 times 3 is 6. And I'll just rewrite this side. Okay, moving down a little bit. Let's go. All right, now I don't have to distribute here because I don't have any variables here. I can just simply solve what's in the parentheses. That's order of operations. So it'll now be 4 times 5 is equal to negative 10 times negative 2, because 3 minus 5 is negative 2. All right, let's continue working. 4 times 5 is 20. And negative 10 times negative 2 is also 20. Well, it looks like this works. Both sides of my equal sign are correct. Therefore, a equals 3 is the solution to this equation.